We're on page 29. Does anyone remember what tangent looks like? Yeah, it's like this one. Tangent looks like this guy, right? Lots of these. Does anyone remember where it starts? Say it again. It is the origin. So we're going to start at the origin, and it just goes like this. That nice straight line, -1, 0, 1. And then those asymptotes are every pi. And so we're going to put an asymptote at -pi/2 and a +pi/2. And I'm going to continue those asymptotes. They happen every odd pi/2. And then the tangent graph is always -1, 0, 1 on that little diagonal. And so this was just a basic tangent graph, which we've seen before. So it's like we've done 6, 7. We just haven't done one little itty bitty part of it that we're going to talk about today. Okay, so you guys, this one was a reminder. What's the period of tangent? 1 pi. Sine and cosine, it's 2 pi. Tangent has a period of 1 pi, so that is important. You guys, I am not going to make us grow and shrink. I'm not going to change the amplitude of a tangent graph. Can it? Yeah, I'm not going to have us do it by hand. What I'm going to worry about are shifting it up and down, boop, boop, or left and right. Boop, boop, that's all I care about. I'm not going to make you make it wider and skinnier. Sound good? So, tangent, just like Beck said, starts at the origin. What's this little +3 going to do hanging out here, though? It's going to move it up 3. So, you guys, that's my vertical shift. We're now moving that origin, if you will, up 3. So, this is my new x-axis. You don't really need that line here if you don't want it. I'm fine with not on this one because it's really just letting you know your new origin is going up 3. And look at what we did before. Here is my origin. I had a point up and to the right and down and to the left. I had these 3 points. So wouldn't my other 2 points on my tangent graph, one's above and one's below like that? You down with that? So we still have, in this case, our vertical asymptotes at every pi. It just took my tangent graph and we shifted it up. So I'm hoping that we feel comfortable with being able to do that. Boom, 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 boom. And so it's just taking our squiggles and we shifted them up 3. Nothing else changed. So you guys, on this guy, my phase shift is still -c/k. The phase shift here is still -c/k. What would be my phase shift on this one? What's -c in this case? +pi/2. What's my k in this case? 1. pi/2 divided by 1 is pi/2. So it's saying take that starting spot, which was always the origin, and shift it right a pi/2. So if I shift that starting spot, excuse me, right a pi/2, then again, I just go up to the right, down to the left. And then on this case, Bob, you agree my vertical asymptotes are at 0 and at pi and at 2 pi. You're down with that, bud?
Yeah.
Great.
So it always stays 2 spaces away, basically, or like it always stays not all the way to the right.
It's always a pi. I mean, it doesn't technically, but what for our intents and purposes of me having to graph these by hand, so it's not absolutely miserable, I'm not going to change the period of the tangent graphs for us to have to graph them.
Do you ever have to do it by hand?
I mean, yes, some teachers do make their kids graph it by hand, but will you ever have to do that on the ACT or SAT? Not at all. So what I'm trying to hit with you guys is the important stuff. We could make everything harder if we wanted to. It's just there's no point to it in my mind. And this is our state champion swimmer, Leva. Go, girl. She got her arrow through the card. That's why I took her picture. She was a sharp shooter. Okay, so what's this tangent of x -1 going to do? Move it down 1. It's just going to move that center down 1. So if we always started at the origin, I'm going to move down 1. Then where would my other 2 points be? Agreed. And my asymptotes are still at negative pi over 2s. Anyone getting sick of these asymptotes? Don't blame you. But tangent, I don't mind too much because we don't have to do too much crazy stuff to it. You good with that, Bob?
Yep.
Where are we going on this hog?
Pretty much doesn't change.
Negative c over k. So it'd be negative pi over 1 would be a negative pi is my phase shift. So I'd have to go over here, right? Do I need to shift it up or down? No. So when I do that, you're like, wait a minute. That just looks like my normal tangent graph. Because then when I create that pattern, boom, 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 that one is my normal tangent graph. Yep. So we've got lots of different equations that can represent the same graphs. Boop, and boop, and boop. All I want to do is do a little pre-teach on this 6-8. It says we've got sine, cosine, and tangent. We're used to those. What are their co-functions? Which one goes with sine, secant or cosecant? Cosecant. So we could write C-O-S-E-C-A-N-T, and how we write that is just C-S-C. Which one goes with cosine, cosecant, or secant? Secant. That shortcut is S-E-C. What goes with tangent? Its co-function is cotangent. Cotangent, and its little shortcut looks like cot. Now, we don't have to worry about those. And in 6-8, we're actually talking inverse functions. And an inverse function is not the same as cosecant, secant, or cotangent. This is how we say inverse sine. We'd say it this way, or arc sine. These mean the exact same thing. Anyone know how we would type it into our calculator? Second sine. Do you agree that it writes it this way? Your calculator will always show it this way. So this is what I'm impartial to. We could write this. It's just more symbols, and I am lazy. You know me. I like to write less symbols. So you're typically going to see me write it this way. Inverse sine, inverse cosine, or inverse tangent. But AP will use, and they'll use this most of the time. They'll sprinkle this in every so often, so I just want to make sure that we feel okay with it. So, and an inverse function. What do we do with inverse functions? Does anyone remember what happens with the x's and the y's? They just flip. They just switch. So I said, recall the inverse function may be found by interchanging the coordinates of the ordered pairs. In other words, the blank, the blank of the function becomes the blank of its inverse. Anyone read my mind on that one? Ooh, what's the fancy word for x?
Oh, the domain and the range.
Aha, the domain, or just like Ritzy was saying, he's like, that's just the x of the function becomes the what, Ritzy? Range, or the y values of its inverse. And then conversely, the range becomes the domain of the inverse. That's a little redundant. These are the graphs of the inverse functions. Again, if my x's become my y's, it's just rotated. Guys, I'm not making us graph inverse functions. Not making us do it. Okay. Does anyone remember when we use inverse or arc, meaning, what if I gave you this cute little triangle and I said 3, 4, 5, what's this angle? Does anyone remember how I'd find that angle?
Arc sine is 4 over 5.
So you're saying, you're like, the sine of x is opposite over hypotenuse, 4/5. How do we find angles? He said it. It's always just the inverse sine or arc sine of that, right? Very good. So then we can go to our calculator, and I'd say inverse sine of 4/5. And actually, this would be back in... Doesn't matter, because we're not going to use our calculators, is what I'm trying to say. I personally am going to have to go put this on degrees since I'm talking about a triangle. And if I did inverse sine of 4/5, I'd get 53 degrees. So to your point, Ritz, anytime I'm finding an angle, I've got to use the inverse function. And that's what we're going to be doing in 6-8, you guys. So check this out. Check these out. We're only going to just do a couple of these because then I want to save it for Monday. When it says arc sine, this is saying the same thing as inverse sine, negative root 2 over 2. Same thing. And you agree, whenever we're doing inverse, we're looking for an angle. So now we're saying at what angle is the sine y negative root 2 over 2?
Using a calculator, we're just looking at the unit circle.
Correct.
I guess it-
We're just looking at the unit circle. Sine, no calculator, Mr. Blake Harville. At what radian, an angle, is the y coordinate negative root 2 over 2? Give me one.
315
In radians?
7 pi over 4.
7 pi over 4. Give me another. Ooh, thank you, Kate. She said my y is negative root 2 over 2 at 5 pi over 4. Give me another in terms of negative radians. Give this to me in negative radians.
Negative 3 pi over 4.
Close. That would be all the way
Negative pi
over here.
4.
Good, Coop. Because isn't pi over 4 right there? So this 7 pi over 4 would be the equivalent of negative pi over 4. Let me show that. Boom. That's pi over 4. This would be negative pi over 4. Yeah? So, am I good with all three of those answers? For sure. AP is good with any of them. But I prefer this one and this one because they're closer to the first quadrant. You know what I'm saying?
Yeah.
All right. Let's just try 2 more. This second one is asking, wow, I've got so much going on here. This next question is saying, at what angle, oh golly, gotta move this guy.
What angle is x?
Oh, yeah. This one's complicated. Oh, this is a big one. You guys, it's saying, we gotta start in the beginning actually. The cosine at pi over 2, they wanna know that. What is the cosine, the x coordinate at pi over 2?
0.
Boop, right there. Then we're going to fill it in like this. Inverse sine of 0. Anytime there's an inverse, they're asking for the angle in terms of radians. So now they're asking at what angle is the sine y coordinate 0? 0.
I did it in radian.
No, that's fine.
2 pi or pi.
Yeah, but also 0 is a radian as well. 0 and then 2 pi are the same spot. What about pi? Yeah, any of those. I love that. 0, pi, 2 pi, 3 pi. Any pi, that y coordinate would be radians. Let's do one more, people. Let's do one more. Come on, little unit circle. Okay. And okay. Here we go. Oh! Inverse tan of 1. People, this is asking, actually, I'm going to do this. Let's get this guy over here. Boop. At what angle in radians is my y over x 1? Pi over 4. This y over x is 1. So I'm going to replace this little ditty with pi over 4. I'm going to keep my sign coming. Sign of there. I got a pi over 4. Then, what's this asking? It's inverse. So it's saying, at what angle in radians is the sine 1? I agree. The y coordinate is 1 at pi over 2. Can we simplify? 1/4 pi minus 2/4 pi. Because 2/4 is a half. What's 1/4 minus 2/4? Negative 1/4. So we got the sine at negative pi over 4. I just simplified what was in my parentheses. The sine, the y coordinate, at negative pi over 4. The y coordinate would be negative root 2 over 2.